Okay, so today we are solving using elimination. Our method is going to be elimination. I like this one the best. It's fast. You might like it. It's kind of puzzly. Not less steps, but it's fast. It's not less steps. You do need to think more. How to solve a system.
What example is this?
It's going to be example 2 or example example 2. It's going to be 4? 3, 4. It would help if I was in the right section here.
Maybe 4.
Okay. They're yelling at me. Yeah, it would be example 4. How to solve a system using elimination. Elimination. Okay, so the first thing that we want to do is we want to write both equations. If they're not already, we want to write both equations in standard form. So slope-intercept form is the way we want to write them if we're trying to graph them. Standard form is the way we want to write them if we are using elimination. Standard form says AX plus BY equals C. That's our goal if we're using elimination. We want them lined up with X and then Y and then a constant. Then we want to stack our equations, one on top of the other. So we're going to write them out, aligned vertically.
Mouse is heavy.
Big old mouse. Then we want to multiply the entire equation by a number that will produce matching coefficients with opposite signs. Matching coefficients with opposite signs. Okay. After that, we want to cancel a variable. You'll see what all of this means in just a minute. Cancel a variable. Solve for the remaining variable. Substitute. Oh my goodness. Hard to believe I said this is faster, huh? Substitute for the eliminated variable. And then the last thing we want to do is check our solution. Really hard to believe. I think this is better. Looks like this is going to be terrible. You're going to like it. Y'all are puzzle kinds of people. And you're really, really smart. So I think this is going to go well for you. You are. You're so intelligent. Did you get a big Santa yet?
Did you not see it?
Oh, we didn't go last night. I know. We went out to the park. That's what we every night. Either we go in our neighborhood or we go to the park. Okay, good. Good for you. All right, here comes example 4. Are y'all ready for it, or did I go too fast? You still needed some more? Ready, set, go? Yep. Okay. Example 4. Let's get down here where we can see what we're doing. So it says x plus 2y equals negative 1. And negative x plus y equals 3. And your first step said check and see if they're in standard form. If they're not, you need them both in standard form. So are they? Yeah, both of them are ready to go. Step 2 said stack your equations. Write them one on top of the other. You want to make sure that they're aligned with x stuff and then y stuff and then the constant. Okay, that's the benefit of putting them in standard form so that alignment happens. Can y'all see that? So we're going to stack them one on top of the other. That has already happened. So we're ready to go here. Then it says multiply the entire equation by a number that will produce the same coefficient with opposite signs. So we're looking at the coefficient of x and or the coefficients of y. And we want them to have the same number but opposite signs. So look at your x values. What's the coefficient of the first sentence in x? 1. What's the coefficient of the second sentence in x? The coefficient of x in the second sentence. Negative 1. Can y'all see that those are the same number with opposite signs? So you don't have to do this step. If you did, which we'll look at in a little bit, I'll walk you through that. But in this case, you don't have to do that part. They're ready to cancel the variable. So the rules here, whenever we're trying to do elimination, you can do two things. You could always multiply. You multiply an entire equation by one number, whatever number is necessary. In this case, nothing needs to be multiplied. And you can add. You can multiply sentences by a whole number, and you can add your two sentences together. Okay? So what happens if I add these two equations together vertically? So what's x plus negative x? It just cancels out. That's that step, cancel a variable. You see why they cancel? Because they're the same coefficient but opposite signs. What if I add 2y plus 1y? 3y. And 3y is equal to negative 1 plus 3, which is 2. Solve for y. Y is 2/3. Now, we need to go back and solve for x. Pick one of your two equations. It doesn't matter which one. And we're going to substitute that y value in. Which one would you like to sub in? The top one. So we need to solve for x. So we have x plus 2 times y is 2/3 equals negative 1. So x plus, when I multiply 2 times 2/3, that comes out to be 4/3. 4/3, good. Equals negative 1. Then we want to subtract 4/3 from both sides. What's another way I might call negative 1? Might call that 1 over 1. What if I want it in thirds? I could call it negative 3/3 minus 4/3. That's a little more clear. So what's x equal? Negative 3 minus 4. Negative 7/3. Dig a deeper hole. Negative 3 minus 4. Take away. So negative 7/3 is x. So our solution here is going to be negative 7/3, comma, 2/3. And your last step here is going to be check it. You want to make sure that that equation or that solution works. We use the first equation to find it. So we're going to plug into the second equation to check it. So I've got negative 7/3 plus 2/3 should equal 3.
Yeah.
What is negative 7?
It's negative 9. Oh, wait, positive.
7/3 plus 2/3, you said makes 9/3.
Yeah.
Is that 3?
Yeah.
Yippee. So we're good. Okay. So it looked like that was a whole lot of questionable steps, right? But it turned out to not be so bad. Let's try another one. I don't think it was so bad. Do y'all think that was so bad? Not too bad? All right, here comes example 5. Example 5. And our equations are 3 plus 5y equals negative 11. And x, sorry, that was 3x. Stick an x in there. 3x. I'm sorry. 3x plus 5y is negative 11. And then x minus 2y is positive 11. So first, write them in standard form. Are they both in standard form? Stack them. Are they stacked? Now look and see what could you multiply one of the equations by in order to create a situation where one of the variables has the same number but opposite signs. Negative 3. So we could multiply the second equation by negative 3. And what that would do is that would allow this x term right here to have a negative 3 in front of it, so that it matched the positive 3 that was above. Can you see that?
You do every number?
Every single number in the whole equation, we're going to multiply by negative 3. Okay, so I like to put brackets on both ends. I've never seen this in a textbook, but it's kind of the way that I do. That way I hit every single term and make sure that all of them get multiplied by that negative 3. So my new equation, after I multiply by negative 3, is going to be negative 3x plus 6y is equal to 33. Yep, it is. Thank you, Marcus. It's negative 33. And the other equation stayed the same. I just am going to rewrite it on top of this one. Now we can add. So we can multiply and we can add. Those are the two steps that we can do. Okay, so 3x minus 3x, we canceled that variable. That's why we needed the same number but opposite signs. What's 5y and 6y? 11y. And negative 11 minus 33? Negative 44. So y is not 4, but negative 4. So now what? What do we do with that?
Yeah, plug it back in.
To either one. Pick your favorite. Which one would you want?
Do you plug it back into the original problem? Like x
Yeah.
minus 2y?
So before you multiplied by 3. Yes. Which one? Are you going into the second equation?
Yeah, why not?
Why not? Okay. So x minus 2 times negative 4 is equal to 11. So what do I have? X. X plus 8 is 11. And then minus 8, minus 8. X must be 3. And we check. 3 comma negative 4. And we use the second sentence to find our solution, so it should be that we can plug back into the first sentence to check it. I get 9 minus 20. Feels like it's negative 11 on both sides.
Oh, I forgot the 4 is negative. Okay.
What'd you think?
That's pretty easy.
Pretty easy? Pretty easy? Okay, here's another one. This is example 6. Example 6 says 2x plus 3y is equal to negative 16. And then 5x minus 10y is equal to 30. Say it louder.
Multiply each by each other to get 10x.
Yeah, you're going to have to multiply both equations by something. In this case, because there's not any way I'm going to get 2 to be 5. There's not any way I'm going to get 3 to be 10 without multiplying both of the equations by something. So at this point, you would want to find the lowest common multiple, right? What's the lowest number? And you're looking at 2 and 5, and you're also looking at 3 and 10. And you're deciding which one of these would be the easiest move. And I think it's easier to take 2 and 5 to 10 than it is to take 3 and 10 to 30. Would y'all agree with that?
Yeah.
Okay, so what are we going to multiply? And remember, we have to have opposite signs. Doesn't matter which one you decide to be opposite or negative. But one of the two equations is going to have to be multiplied by a negative number.
Do the top one.
Do the top one, he says. Okay, so what are we multiplying the top one by? Negative 5. Okay, so times negative 5. You could put that negative 5 out in front if you wanted to. There's no... Probably out in front's better. And what are we multiplying the second equation by? Positive 2. And I really, really, really prefer to have brackets around the whole equation so that you can see I'm catching everything here. So when we push that negative 5, that new equation is going to be negative 10x. What else? Minus 15y is equal to 80. And it's positive 80.
Yeah.
Positive 80. And your second equation is going to be what now? Positive 10x minus 20y equals 60. Good. Okay, are we in agreement? Now, the benefit of creating that situation, same number, opposite signs, is that what? You can cancel your x's. If we had gone the other way and met the y's at 30, we could cancel the y's. Okay, you don't always cancel x's. You could cancel whichever one works best. So now we add, remember multiply and add. Those are the only moves we can make. We cannot subtract. Negative 35y, keep talking.
35.
140.
Y equals 4. Y equals negative 4.
Okay. Y equals negative 4. Plug into what, Katie? What do you want? The first one, the original equation. You don't want to go into one that you multiplied. You want to plug into the original equation, just so that if you made a mistake, you're not plugging into something that you created. So 2x minus 12 equals negative 16. I'm adding 12 to both sides. 2x is negative 4. Am I going too fast? X is negative 2. So my solution, I believe to be negative 2 comma negative 4. We should check that into the second equation because we already used the first. And I get negative 10 plus 40 is 30. You have any fans of this method? Anybody actually like this one?
Yeah.
I like this one the best. You still know? No? What do you think, Benedict?
Like the second.
You like substitution better?
Yeah.
Okay. So I like substitution better if I can see the naked letter situation. Sometimes they're set up that way, and I don't want to spend time rewriting it into standard form to do this. So if it's set up where one of my equations is in standard form and one of my equations is set up in slope-intercept form, y equals blah, 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 then I'm just going to plug that stuff in for y and be done with it, instead of putting them both in standard form to do this. But if they're both in standard form, you can guarantee I'm not going to graph them. I'm not going to go in and put them in slope-intercept so that then I can graph and blah, blah, blah. Who has time for that? I'm going to cancel a variable and move on, right? All right, so let's go on to example 7. Example 7, we have x over 3 plus y over 6 is equal to 3. And x over 2 minus y over 4 is equal to 1. And this is yuck by all standards. I think it's double yuck. What do you want to do? What do you hate about this the most?
Fractions.
The fractions. Thank you, Wyatt. That was aggressive. Get rid of them. How are we going to get rid of the fractions? How can we clear the fractions? Huh? We learned about this before. Lowest common what? Lowest common denominator? So what's the lowest common denominator? I'm giving it to her. What's the lowest common denominator on the first equation? 6. Multiply that whole sentence by 6. And then let's go from there. If I multiply x over 3 by 6, what do I get? So that's a 6 divided by 3 is, what's 6 divided by 3? 2. Right? So this goes to be 2x. What's 6 times y over 6? Redemption. You got it. Just be y. Ah, she's onto something. And 6 by 3 on the end? That one's 18. So our first step here is clear the fractions. Get rid of them. We hate them. We don't want to deal with them. If at all possible, we're going to get rid of them. What's the lowest common multiple on the bottom? 4? Because it's a 2 and a 4. So 4 by x over 2 makes 2x. Minus y equals 4. Okay. Now we need the same number but opposite signs.
Wait, why? We got it in y.
We got it in y. Good. So this is trying to get you to see and think, right? So I don't need to get my x, I don't need to multiply by -1 to make my x's cancel, because in this setup, my y's cancel. So 4x equals, what?
Right?
22?
I don't know why I have 3.
4x equals 22? And x is, if you reduce that down, it's 11 halves. Now what, Marcus? Oh.
Plugging it back in.
Plugging it back in. I don't want to plug 11 halves into a fractiony thing. So I'm going to take the risk and plug into this 2x plus y equals 18. So I'm plugging 2x plus y. So 2 times 11 halves plus y equals 18. What happens when I do 2 times 11 halves? Well, 2 divided by 2 is
Just cancel out.
just 11. Just 11 plus y. That's what you thought, right? 11 plus y is 18.
Subtract the 11.
So y is
Y equals
7.
Yeah.
Just 7. Okay. I guess. So let's check it in the other one. 2 times 11 halves minus 7 is 4. What's 2 times 11 halves? I'll give you a shot at it again. 11. 11 minus 7?
11 minus 7 is 4.
It is 4. So we're good. Okay. This one was gnarly. They're not always, but I would still take elimination in this problem, having to clear the fractions, over having to substitute a variable or having to graph it. I think elimination is still your best option, even if it's gross. Okay. Let's do another one. Killing you today. Working you like a Trojan. All right. This is example 8.
I thought we had homework.
Any minute. Example 8 says 9 minus 2y. That's one of ours. X equals 9 minus 2y. And then x plus 2y equals 13. Now, first, if I wasn't teaching this lesson right now and I just saw this on paper and I had options, I would do substitution here because it's already set up with a naked variable. Okay? But because we're not doing that, we're doing elimination, we're going to move it and make sure that it's in standard form first. So what do I have to do to this top equation to get it to be in standard form?
Subtract the x from both sides.
Okay.
And then,
Add 2y.
What if we just add 2y? What if I move that 2y piece over yonder?
I didn't see that.
So what if I just add 2y to both sides? Now I have x plus 2y equals what's left on the right? 9. So this is my new set of equations. We're going to do what? Stack them. And then
Divide, times a negative 1.
times a negative 1. Which one do you want to multiply by negative 1? The bottom one? Multiply this guy by negative 1. I like it. So the top is x plus 2y equals 13. The bottom is negative x minus 2y equals negative 9. So what happens?
Bro, pause. They all cancel out.
Pause. They all cancel out. This is problems. What's left on the left side? If I lost all my variables, what's left over there? 4. And on the left side? Nothing, right? 0. Is 0 equal to 4? No. This is false. So there must be no solution. So what kind of system? Oh, they're parallel. See, all of the pieces are coming together. No solution. These must be parallel lines. It must have been that if I graphed them, they never crossed. You know that's the case when you end up with a false situation. So all your variables canceled. Read what's left. If it's false, there's no solution. Okay? These must have been, what do we call it? It's a what kind of system? Are y'all looking back at your notes from yesterday?
No, it's like the system of lines. Like the name of the line.
Britton's looking.
I forgot it. No, they're like in it something. There's like a
Inconsistent.
inconsistent.
Inconsistent system where your lines are parallel.
I knew it was a weird word.
Yeah. All right, one more. It's the last example. The last example for today. Example 9. We have x plus 3y equals 2. And we have 3x plus 9y equals 6.
Multiply the top by negative 3.
Multiply the top by negative 3. Multiply the top by negative 3, he said. I like it. So that new top sentence is going to be what?
No solution.
Check it. Negative 3. So y'all are yelling at me. My variable's canceled, right?
Everything cancels.
Everything cancels. So now I'm left with what on the left side? Nothing. And what on the right side? Still nothing. True or false?
Oh, true.
True. 0 equals 0.
One solution?
True. Not one solution. We've had one solution. That's where we were finding an ordered pair. More than 2.
Infinite.
Infinitely many solutions.
So they're like on the same line.
They're the same line.
I forget what
Infinitely many solutions. They're the same line. So your answer here is going to be all real numbers or infinitely many solutions. These are the same line twice. If you had graphed them on a number line, one of your lines would be here. And if I'm super skilled and careful, I would draw the same line right on top of that one. You would see 2 lines in the same place. What's the word for this? They're coincident, or it's a what kind of system? Starts with a D. You wrote it yesterday. Dependent system. Dependent system. So you got 2 cases, okay? When everything cancels. You got 3 cases, actually. You can actually solve it. You can get a solution. That's independent system. It costs 1 time. Or your letters are going to cancel, and you end up with a false statement. 0 equals a number. That's going to be no solution. Parallel lines. Or everything in their dog canceled because it's the exact same line twice. That's infinitely many solutions, a dependent system. Okay? Yeah? Pretty good? You have a big homework assignment. It's posted in Canvas, and I'd love to grade that on Monday.
Big, what do you mean by big? How many
Well, it covers both days.
How many questions?
Well, I don't know.
Why have they not divided?
Y'all quit panicking. It's not hard, YouTube. It's not hard.